In this educating video, I want to show you why we care so much about this form that we call vertex form. And I'm going to show you by plotting this function. I'm going to show you how to plot this function. I'm going to show you how we can identify these things that we call the vertex, how we can determine if our graph opens up or opens down, how we can determine what we call the axis of symmetry, how we can identify the zeros from vertex form. But before I do, let me just go ahead and write over here the general equation or the general function for vertex form. So we've got y equals a, parentheses, x minus h, all squared, and then plus k. So before we go any further, just take a minute on your own and see if you can identify what a, h, and k are in our expression. So hopefully you were able to identify our A, our H, and our K in the expression to the left here. So if we look at the general expression, we see that the A is the number in front of the parentheses being squared. So I find my parentheses that are squared, and I look at the number in front of the parentheses. So in this case, it's a 2. So in our equation, A is equal to 2. Now this one's a little bit tricky though. So we look at our general form and we see that we have negative h. We've got negative h here. So really I need to write negative h is equal to, I look inside my parentheses, this negative h is the second term inside the parentheses. I look at our expression and the second term inside the parentheses is positive 3. So really it's negative h is equal to positive 3. So 3, which means that my h is equal to negative 3. Now finally, we want to figure out what our k value is. So I look at my k. The k is whatever's being added to this first term that has the parentheses squared. Here's my first term with the parentheses squared, and I'm adding 1. So this 1 here is our k value. So I write k is equal to 1. So our k is equal to 1, our h is equal to negative 3, not positive 3, and our a is 2. Now before we graph this, before we start constructing the graph, I want all of you to identify the vertex and the axis of symmetry first. So you always need to identify the vertex and the axis of symmetry before you start constructing your graph. And in a few moments, you'll see why. So our vertex is going to be, now actually before I put down what the vertex is, make sure that you have your worksheet ready. You probably want to take notes right here. Write down what I write down, so that way when you go back to work on problems 2, 3, 4, and 5 of your homework, you'll have something else to refer to. Because I'm going to write down what the vertex is in general first, and then I'm going to write down the answer for this problem. But for all the ones on your homework, I just want to see the answers. But here, I'm going to write down in general what the vertex is. So the vertex is always going to be HK. It's always going to be HK. So we've already compared our general form of vertex form and compared it to our expression. We found that our h is negative 3. And we've also found k by comparing our expression to the general vertex form, and we found that k is equal to 1. So my vertex is equal to negative 3 and 1. So it's always just going to be HK, H comma K. Now to identify the axis of symmetry, because that was pretty easy, to find the axis of symmetry is also very easy. The axis of symmetry is always going to be H. So our axis of symmetry is H, which in this case is negative 3. Now you should ask yourself, why in the world did we need to find the vertex and the axis of symmetry first before we started constructing the graph? Now here's why. So to explain why, I'm going to go to the next slide, and I'm just going to sketch really fast a parabola that looks like this, and also a parabola that looks like this. Okay? Now, at each point along these parabolas, we have points that I will mark in yellow. We have a point here, which is at the absolute minimum. This is the lowest point that we could ever have for this certain parabola. That's the lowest point. Now, if we're looking at this parabola, okay, we have a point up here. We have a point up here, and that's the absolute maximum point, or the absolute maximum value that we could have along our function. And we call these points the vertices, or if you're just looking at one, we call this point the vertex, and we call this point the vertex. So this is the vertex in this case, and this is the vertex in this case. Now, in the case to the left, okay, this parabola is what we say is opening up. Now that kind of makes sense, right? If you look at the shape, it looks like it's opening upward. So this shape is open, or opens up. And when you have a parabola that is opening up, your vertex will be a minimum. So in this case, when we have a parabola that is opening up, our vertex is a minimum. And when we have a parabola that is opening downward, so this is what we call open downward. So this is opening down, opens down. Okay, that opens down. We would say that our vertex is a maximum. Our vertex is a maximum. So the first thing you want to do is go back to your graph, and when we're going to graph functions that are in vertex form, the first thing that you want to do is you want to make a point where your vertex is. Now, if you remember, you guys have probably done this before, our -3, the first number inside our parentheses here, tells us what the x value of our vertex is. So here, our x value is -3. I go to my graph and I say, okay, -1, -2, -3, and then I go up to the y value of 1. So I'm at 3, I go up 1, and I'm going to make a point right there. At -3, 1, and we call that point the vertex. So this is the vertex. It's either going to be my absolute minimum, or it's going to be my absolute maximum for my graph. Now, why did we care about finding the axis of symmetry? The reason is because if you look at the parabolas, okay, you'll see that they are symmetric. Okay, so if I were just to plot from here all the way up to this point, and then place a mirror right here, it looks like the right-hand side is a mirror image, okay, a mirror image of the other side. So these parabolas are symmetric. This side looks exactly the same as that side. And the same is true for when the parabola is opening down. So here, okay, if I look at this side, it looks exactly the same as the other side. So we need to draw what we call an axis of symmetry. So I would draw my axis of symmetry. I'm going to draw it in green. I would say that my axis of symmetry here is right there. So you can see that whatever is on the left-hand side of the axis of symmetry is symmetric, or looks the same as what's on the right-hand side of the axis of symmetry. Likewise, over here, if I want to draw the axis of symmetry, I would draw my axis of symmetry down like this, all the way down, and I'd say, okay, let's test and see if this is the axis of symmetry. So I look at my left-hand side, and I see that my curve looks like this, and then when I cross over the axis of symmetry, I see that it looks like a mirror image of what was on the other side. So you can see that this looks exactly the same as that. So it's a mirror image, so we call this the axis of symmetry. So green is axis of symmetry. Symmetry. Okay, there and here. All right, so let's draw the axis of symmetry on our graph. we said that the axis of symmetry is h is equal to -3, so I just go and find -3, and I draw my axis of symmetry there. Now, the reason that we're doing this, you'll see in just a moment, is because it's going to make plotting a lot easier. So that way we only have to find points on the right-hand side, and then we'll automatically know what goes on the left-hand side. So let's just go ahead and solve for a couple points here that we can plot. So let's just go ahead and do maybe 2 points on the right-hand side of the axis of symmetry. So you always want to get at least like 2 or 3 points on one side of the axis of symmetry. That's sort of the goal here. So I look and I say, let's start with -2, and let's do -1 and 0. So I'm going to do that on a different slide. So let's go to the other slide, which I've got over here, and you can see that I've already rewritten our function, and I've made a t-chart. And I picked -2, -1, and 0 because I just wanted 1 or 2 points on only one side of the axis of symmetry. So some of you may ask, could you use -4 and -5 and -6? Absolutely you could. I'm just choosing -2 and -1 because they're smaller numbers, and it may make it a little easier to work with. So I go back to this slide. The way that we do this, I'm going to kind of rush through this because I feel like you guys can do this. So -2 I plug into my function. I plug -2 in for x. So what I would get here if I was doing -2, I do -2 plus 3, and then plug that into my calculator, square it, multiply it by 2, plus 1, and then I find my y value. I feel confident that all of you could do that. If you're not sure how, go ahead and try it. Just try plugging -2 in for x, and then just evaluating this, and check to make sure that you get the number 3. The number 3. Likewise, when you take -1, you plug it into here, you get -1 plus 3, so that'll give you 2. 2 squared, that's 4. 4 times 2, that's 8. Plus 1, that's going to be 9. Feel free to check this in your calculator if you don't believe me. And then the same for 0. When I plug 0 in, I get 0 plus 3, that's 3. 3 squared, that's 9. 9 times 2, that's 18. 18 plus 1, that's going to be 19. So these are my 3 points that I want to plot. -2 and 3, -1 and 9, 0 and 19. Now make sure you don't get these confused, okay? The -2 is going to be what's on the x-axis. The -1 is going to be what's on the x-axis, and the 0 goes with the x-axis. The 3, 9, and 19 are what go on the y-axis. So let's go back to our graph. So if I want to plot the first point, which is -2 and 3, -2 and 3, I find my -2, and then go up to 1, 2, and 3, and I make a point right there. And then my next point is -1 and 9, so I find my -1 and go all the way up to 9, and that's going to be my next point. Now you can see that the other one that was 0, 19, 19 would be off the graph, so I'm not even going to worry about that one. I'm not going to worry about plotting the 0, 19. So right now I just have these 3 points, which is perfectly fine because since we have our axis of symmetry, we know that this is going to be symmetric along this axis. So what I could do is I could look at this point, I find this point, and I say, if this is going to be a symmetric curve, what could I put on the other side of my axis of symmetry? And my other point is going to go right here. Okay, you see that? So if this were like a mirror image, this point would be right here on the other side of my axis of symmetry. Then I go up to this point. It's 1, 2 places away, so I go back to my axis of symmetry, 1 and 2 places away on the other side. 2 places away on the other side. And now you can construct your curve. So what you should get is you make a curve that goes through all of these points, and I'm going to do my best. Oh, that was terrible. That was awful. Let's try that again. I'm going to do my best to make this go through each of these points, and you can see that it makes a parabola. So that's the best that I could do on my iPad, drawing that parabola, but there it is. That would be a plot. Now feel free to take this and plot it in Desmos as well. You could take this function, right here and plot this in Desmos to see if you get the same thing. In fact,